Okay. Thanks a lot, Tracy. Really appreciate it. So, just in terms of where we are with large language models and this series, we've done two already. So, the first one was fine tuning your own large language model, which we did earlier in the spring. And then we did another one on dealing with structured data as opposed to unstructured data, which most people associate with a language model. You're ingesting something like a book or a document that's unstructured. So we did structured because we deal with a lot of structured data in our business. So this time, what I wanted to do was take a step back, and because the environment has changed so much in large language models, just talk about what's going on, what are the tools available to everyone, what's moving, things like that, and try to leave room at the end for lots of questions, being very interactive. So here we go. First thing I did is I took the title of this presentation, Large Language Model Environment. I fed it to Bing, and I asked it to make me an image, which it did, sort of an odd image of this doctor-looking person who looks a little puzzled, and it put gibberish in this thing he's holding. So there's an example of it really not hitting the mark, and I have a couple more examples in there, but there's a large language model at work. So let's just go over again how we got there. How do models like that work? And if we were to employ them, as we have in two other sessions or in the future, this is the general path you would take. So you start with a model input, and it could be a corpus, like a document. And we'll just keep that as an example, because we can also do images and audio too, and video, but that gets more complicated, and I think people are more comfortable with text. So from that input, say a document, you create embeddings, which are numerical equivalents of the text that you put in. This helps the program understand, because it can't understand words, it understands the numerical relationship between the words and the data that it creates. And from that, it can measure distances between words, which is the original large language model function. How far away in a sentence is one word from another, and you can infer meaning by that distance. But we've moved a long way away from those days. So now we're in what's called transformer network, or tensors, which we're going to talk about the company that invented that and makes that available to us. This makes a very high dimensional state, and it is also a neural network with hidden states in there. And I know this frustrates a lot of developers because you want to be able to see what's going on in there, but you can't, because it doesn't exactly make sense to a human. These hidden states are divided into things that we do work with, though. So the first state, the first type of data you get is the batch size. So the idea is, how many sequences of, let's say, sentences are you going to process at one time? And this gets into how much processing power you have, which is another thing we're going to talk about in just a minute. Then there's the sequence length. So if you have a sentence, sometimes you're limited, as you are with BERT, which we've worked with BERT models up until now, to 512 tokens. It's not words, it's a token. And you then need to break up your input into various overlapping sequences. And then there's the hidden size, the last state, and those vary as well. With BERT, it's a length of 768. So we refer to these as high dimensional because they're very long strings of data with very precise numbers. So BERT is not a conversational model or a generative model. It only does 768. Like a ChatGPT would have a much longer dimensional state, upwards of 3,000. And again, we're going to talk about the companies that support this overview in just a second. And then, of course, you have your model output, which is either generative text or the next word or the image we used in the beginning of this presentation. This image is output of a large language model. So I wanted to go over, and with Gracie's help, we just put together some news stories, what's going on with large language models. Everything is linked. We're going to distribute the presentation so you can dig in and follow it. And I'm just going to go over very quickly. The idea is that the Senate has now gotten involved with attempting to govern AI. Oddly enough, 60 Minutes ran a story in the spring with the CEO of Google in which he begged the government to intervene, especially on the development and distribution of large language models. This is fairly unusual, and I can only suspect that the output of any senatorial work here is going to be restricting entry and increasing the barriers to entry for small companies to do this type of work. Of course, there is a risk that they're trying to protect against. This is what often happens when the government gets involved, and the perfect case would be when Microsoft was sued in the 90s. The result was they blocked a lot of competition by invoking the laws that they did. Another thing that's gone on is, if you're familiar with Section 230 of the federal code, it protects companies like Facebook and Twitter when someone makes a comment on the platform that, let's say, incites violence. Twitter or Google or Facebook can't be sued. So that, unfortunately, does not seem to protect large language models. So let's say a model picks up hate speech when it's being developed and then outputs it in a model output. It seems as though, and the Supreme Court Justice Neil Gorsuch has also backed up, that 230 won't protect a large language model. And in response, Microsoft has offered legal help to people who get sued by using their models. This is going to be really interesting. We just got to watch it because, it's a totally different environment than we're used to with social media. That I find really interesting is everybody's talking about processing power. If you look at startups in this space, most of the expense in the investment that's made is in computing power, but more specifically in GPUs that can handle this kind of data. And it's really a problem. There's NVIDIA stock is through the roof, and the delivery times for their computing systems that have GPUs are a long time. So someone, and this guy's called the Bloke, which I have a link to his Discord page, has come up with a way to utilize the GPUs in a Mac to do work on large language models. This is a big deal because if you look at the price of, say, an A100, which is the standard GPU from NVIDIA, it's about $33,000 if you can get one. So here's someone doing this work on a consumer product and doing pretty well. And that's another odd thing about the large language model environment, is that it is hardware dependent and specific to certain manufacturers of hardware. So then the other thing I want to talk about is this idea in our space of a mom who has a very sick child turning to ChatGPT to get a diagnosis and successfully doing so. Now, her comments in this story, I think, are really relevant. She said, no matter how many specialists they saw, they would only stick within their individual areas of expertise. And being in healthcare for many years, I can appreciate that because physicians are forced deeper and deeper into their area of expertise so that they can do better in reimbursement. And I think this has a downside in that they're only looking in their lane. They're not looking at the whole person. And then she goes on to say that, no one wanted to solve for the greater problem. She has a sick kid. Everyone's looking just at their own little world. Say you're a neurologist versus a psychologist versus all the different specialists they saw. No one stepped back. But a large language model by default is going to step back and be able to look. I got things going off here. Be able to look at all the indications of someone's health equally and across the board. And I think that's going to be really helpful to us on the good side of where we're going with large language models. My news sources I get are one's called Ben's Bites. The other is Medium. Medium often charges for their content, so there's a little bit of a warning there. So I want to finish up by just looking at the LLM environment, the large language model environment. I've divided it into 3 lanes. So we have the model makers on top, picks and shovels, which are in any sort of new technology or social movement. You always want to look at people providing the tools for the people that make either the models themselves or whatever else we're talking about. And then who's making consumer facing, if I can, in healthcare, tools in the space. So without further ado, let's just quickly go over the model makers. And we've already talked about BERT. BERT comes from Google. Bard is the consumer-facing website you can use for free. That's a generative model. Now, ChatGPT is out there. We don't use it a lot because it charges money for each interaction. But on the other side, in the open source world, there are many models challenging ChatGPT's supremacy. So one of them would be Meta's Llama. And then also another one called Falcon. And that comes from the United Arab Emirates. So I want to show you how you look up these models. So we go to Hugging Face. So Hugging Face is the not only the transformer inventor and company that controls the transformer models, which are helpful for other things, not just large language models. They also serve up the community and a lot of the code around navigating large language models. So if I type in Falcon, it's 180 billion parameters that go into the construction of this generative model. This is their model card. And it's really helpful because it'll tell you where it comes from and what it does. So it does text generation, and also it'll give you sample code of how to implement this model, which we might do in a future session. Some of these also have a way to interact with the model, so you can actually get output right from this model page. So that's a useful thing. We have the Hugging Face link in there. And then there's Microsoft. They've worked a lot with ChatGPT. It looks like they're going off on their own with this Gorilla AI, and I think they need some help with their logo because it's a little scary. So the most interesting lane, I think, is the picks and shovels. So we've already talked about Hugging Face. That's the smile with the hands. LangChain is another topic that goes a little bit deeper into helping people publish their models and all the tools you need running up to the point at which you publish the model to the general public. So that is one I'd really like to dig into in the future. Now, we talked about memory and how compute intensive this process is. Pinecone, and there are others, is a company that specializes in what's called vector databases. So a database of very exact numbers, it's very long, and enhancing the performance of those data sets. So when a user hits your LLM application, a company like Pinecone will help them get the response back faster, more accurate than you could, leaving it in a normal database structure. So another one to watch is a company called K. And what they specialize in, which is yet another area that we might want to get into, is they're end-to-end. So they'll give you the data, they'll generate the embedding, and then they optimize how the model runs in a customer-facing mode. And they are built for RAG, and RAG is an acronym we're going to want to learn. It's called Retrieval Augmented Generation. And the bonus of RAG, unlike other generative tools out there, is, let's say you're a big company and you have a lot of data, and you build a RAG model that is specifically targeted, let's say, at your data repository. When a user bumps up against the RAG model, they only get responses back from the data set. The function of the large language model there is just to coordinate how the data that the company owns is distributed back or presented back to the user. So you don't get in trouble with, let's say, a hallucination or the model bringing back data that's irrelevant. You can also have the model, the RAG model, specify where exactly it got each chunk of data. So if you have a massive data set like we do, it'll say, I got this out of Edward, and here is the table it came from. This is why I gave you this response. So there's a ownership there. I think that's really helpful. So RAG be certainly very helpful for us in the future. And then just skipping around, if you want to learn more about the LLMs in general, James Briggs is someone, he's a podcaster, but he's also a consultant. I highly recommend his work. His videos especially are very useful. The Common Crawl is another tool that is very useful in developing models, because what they do for free, they crawl the internet, and then they make those stripped out pages, just raw text, and just the way Google would in crawling websites. They make this available as data sets so you can train your large language model on them. You can even specify what type of data you want to crawl. So it's a very helpful, completely free service for people that develop large language models. And then, of course, NVIDIA and AWS, NVIDIA being on the hardware side, AWS being on the how do I process the data and then serve up my app. And then the story I told you about with using a Mac to develop a large language model was developed by someone called The Bloke. He's on Discord. There's a link to that Discord site. So finishing up, what I wanted to get to were the consumer-facing models that are out there. There aren't too many, really, and even fewer in our vertical. But one that is not really quite available yet and is called Duet. And it's from Google Workspace. And what they've done is they've integrated large language models into the Google Docs environment. So you can, if you're making a presentation and you want an image that's your own, it's developed just like this, the image I showed you at the beginning of this presentation, you can type it in and it'll present and create that image for you. You can also look across your other documents, and it'll pull data from your documents in Google to help you do research in creating a new presentation or document. So this is being released now just to a select group of people. I've put in, and I have not received permission yet. So Copilot from Microsoft is basically the same thing. They're building a large language model on top of Microsoft Office. Now here's an interesting one. Elto, what they are is customer service via synthetic agent, a large language model. So imagine that's the front end of your customer service experience. You call in and you're not talking to a person, you're talking to a large language model. And of course, look at who's buying this. So United, Optum, Blue Cross, and Humana. We have for a long time used this technology in our case management area, and it's called ELIZA. It came out of MIT many years ago. And ELIZA makes outbound calls on behalf of our case management. So it's interesting to see that happen in customer service as well. Lily, which I'm not going to show you, Lily is a LLM psychotherapist. And they also say friend in the website. I've used it. It's not really that good, but I think it's the beginning of something. You know, imagine we're having trouble scaling in healthcare, and Lily, you know, with qualified doctors, things like that, if you turn it loose to a large language model, the scale problem goes away. And the last one I want to talk about and see if we have any questions is this one's the sleeper in the group. It's called CodeRabbit. It's an LLM designed specifically to help people code and generate code automatically. So if you go to Google Bard and you say, Bard, make me Python code to do X, it'll do it. I've found it's often filled with errors, but CodeRabbit is trying to make it so that you as a developer in a company are going to CodeRabbit first, getting your code out of a large language model. And this would create, I believe, an environment where we're going faster and faster in the development of code. We're using large language model as a tool to help do development. So with that, I'm wrapping up.